Dear participants of the ICSF2021, let me introduce report titled Determination of economically viable option of liquidation, the consequence of external dam deformation. Authors Yevheniy Babets, Oleh Anisimov, Oleksandr Shustov, Vitalina Komirna, and Iryna Melnikova. Presenter Oleksandr Shustov, Dnipro University of Technology, Ukraine. The dump number 2 of the PGSC Central Ore Mining and Processing Enterprise excavator is located at a distance of 12 kilometers from the open mine in the Oleksandr Hollow. Loose and rock mass are stored in the dump, which are delivered by rail transport. In fact, the dump is poured in succession in several tiers. At the dump number 2, the overburden rocks is accepted at 2 dump dead ends, and it is dumped with the help of EKG 8I and EK 1070 excavators. Overburden rocks in the dump number 2 of the PGSC COMPE is delivered from the faces and reloading points of the open mine number 3. The transport development system is used in this open mine. As a result of the landslide that occurred on the dump number 2 of the Petrovsky open mine of the PGSA's COMPE, 1.42 hectares of arable land were disturbed. There was a need to take measures to eliminate the effects of the landslide. In this regard, options for the further dump operations were considered. Deformation in the form of landslide with the following parameters appeared on the section of the southwestern side of the dump number 2. The length of the landslide manifestation was 410 meters. The depth on average was 7 meters. The volume was 850,000 cubic meters. Landslide area is 85,000 square meters. It should be noted that previously no deformation were observed in this part of the dam. In the area of the dam formation, there is a complex relief with a hollow. The negative aspects include the very low strength of rocks placed into the dam, mainly clay loams, which have a high plasticity at the natural humidity of 21–25%, the soil of which also contains different by their physical and mechanical properties loams. Therefore, the following tasks need to be solved. Using geophysical methods to determine the presence of aquifers and their impact on the dump, to consider possible options for the development of works on the dam taking into account the formed deformations, to determine the stability of slopes according to the proposed models of development, to choose the best technical and economic indicators. To solve the task, it is necessary to determine the most economically feasible option for the development of works on the dam, where the processes of landslide deformation and protrusion in its soil outside the land allotment of the enterprises. To solve the tasks set forth in this work, the following research methods were used: geophysical method of the Earth's natural pulsed electromagnetic field, the methods of algebraic addition of forces, computer modeling, graphical and analytical methods, economic comparison of accepted technological decisions. To determine the stability of the dams, the methods is used proposed by the Institute Viogam. From the upper edge of the slope shown in the figure, in one of the scales adapted for surveying documentation, the value of the width of the slide prism A and the vertical value of H90 are set. Studies have shown that the sliding surface of the slide prism for this conditions is smooth curvilinear, the form of which is close to round cylindrical. The location of the most stressed surface in the rock mass adjacent to the slope coincides with the location of the calculated surface with a minimum safety factor. This surface is defined by stability calculations taking into the account the obtained physical and mechanical properties of rock, as well as when testing wells it became clear that the rocks are not flooded. Therefore, the calculation is carried out under condition of limit equilibrium of forces. During the work performance, it is offered to consider three variants of the decision of unscheduled works on the landslide liquidation. Option 1, removing the landslide to the boundaries of that land allotment without allocating of additional land and determining the possibility of other storage the overburden rocks in this area. Option 2, to carry out land allotment on the slide section from slide action and to define possibilities of the further of overburden rocks in conditions of the formed landslide on the dump. Option 3, to carry out land allotment on a slide section in conditions of the formed landslide on the dam to form a support prism from slide action and to define possibilities of other storage of the overburden. For different variants, taking into account the obtained sections, the safety factors were set. The calculation sum for the option 3 is shown in the figure. Calculations were reduced to the search for sliding forces and restraint forces. Option 1 provides this removal of the landslide to the boundary of the land allotment. It is not possible to remove only landslide due to the reduction of the safety factors. To reduce the load on the dump, the option of removing a part of the rocks and the upper horizon between the marks plus 175 to plus 160 meter is considered. According to the calculation data, the safety factor is the survey open mine, 210 survey axis for the dump after removal of the rocks with the formation of the resultant slope 15 degree makes 1.43. This figure is sufficient for a stable position. When calculating the safety factor in the area between the marks plus 160 and plus 124 meter, it was determined that this area is not stable. That is, significant volumes of landslide are possible in this area. Removal of the landslide as well as the extraction of waste rock on the upper ties is carried out by a hydraulic invent shovel type excavator and the laying down of the slope with IK excavator. Removal of the rock mass is carried out by the dump trucks to the dump where they unloaded and placed by means of the bulldozer. To remove the landslide, it is necessary to form a road, to lay down the power line and drive the IK excavator to the place of the landslide to the upper tires. Landslide rocks are partially used to form the loading prison. For this purpose, a bulldozer must be used. When the landslide removal is finished with the help of an excavator, a trench of the water drainage ditch is formed and straining works are done with the placement of concrete slabs inside the ditch. Option 2, the formed landslide remains within the existing limits. The works on the construction bypass ditch. Option 1, along the landslide with reinforcement works and the placement of the concrete slabs are performed. Legislation regulates the issue of land allotment for the dump. Option 3, the same works are performed as in the second option, but the road from the dump to the landslide is being reconstructed. A reloading point is organized at the dump. At the reloading point, the rock is shipped into dump trucks by an excavator and delivered to the landslide place. A pioneer embankment on a horizon of plus 145 meters is formed in the area of the landslide site. The formation of pioneer loading embankments is done by a bulldozer. The rock mass delivered by dump trucks is unloaded on the loading embankment and formed by a bulldozer. From the point of view of technological decisions, the third option is most effective, which allows to place in additional volumes of our burden rocks, both in a loading embankment 385.14,000 cubic meters, and to form a dump within a height within design contours, providing the stability of the dump. Decision on the effectiveness of open were made taking into account economic indicators. To determine the economic indicators of option for the development of works on the dump, the indicator present value and investment was used, which is calculated to obtain an idea of the current value of the total investment cost of the enterprise over the years. According to the results of calculation in the table, the technical and economic indicators for the formation of the final contour of the dump number 2 on the MPA are shown. The main operations costs for the formation of the dump over the years are shown in the figure. In this slide, the calculations are presented on the slide 9, and conclusions presented on this slide 10. And thank you for your attention.